once again, our home plate for tonight, pages 348, 349, odds only. I mean, unless you want to do the other ones again, that's fine. All right. Our objective, once again, I can identify rational zeros of polynomial equations. We're still on the same objective. Today we're going to look at a couple more things that we needed to see in order to finish up. And you saw some of those things in yesterday's home play with number 6 and also with number 12. Some of you got a little bit stuck, but I'm going to show you a couple of things that we can do from there. So we don't need a Freire model. We already know what polynomials are. Yesterday we covered zeros and rationals, and then we covered the rational theorem, the rational zero theorem. Then from there we got started with 1, 2, 3. Is that correct? That's just tricky. All right. Copy this one. Example 1 mega cube. How come that dog's always barking? Or doggy. All right, the instructions, you don't need them. It's the same one that we started with yesterday. So I'm going to go through the process one more time just to make sure we got this. Okay, here it goes. I'm going to break it down. Step 1. I need the constant over the leading coefficient. So I need a constant. What's my constant? My constant is 10. I need a leading coefficient. Leading coefficient, by looking at it in standard form, the first term, it's the number that leads the whole polynomial that's multiplying the variable. What's that number? If there is no number in Mr. Q, then it's a what? 1. From there, we take those two, and each one we need to find all possible factors, pairs of factors. I'm going to start with 10. 1 times 10, 2 times 5. Are there any other? No, so I'm going to write all these as my factors. 1 times 2 times 5 times 10. Because 1 times 10 is 1. All right. And 1. All right, so let's see. 1 divided by 1, 1. 2 divided by 1, 2. 5 divided by 1, 5. And 10 divided by 1, 10. All right, to find out which one, and by the way, these are my possible rational zeros. Possible. All those. So step 1, you get this, factor it, and find your possible. Step 2, we need to test these using synthetic division. Where do I start? I start with the first one. So I write 1 and divide that in here using synthetic division. That means I'm only using the coefficients. 1, 8, 17, 10. Bring down the first number. Always you bring it down the same way. And then we start with the process we already know. I'm just going to show it one time here again. 1 times 1. 1, and that one we bring it up here once we multiply it. From there, from this point forward, what do we do all here? We combine. So what is 8 plus 1? 9. We'll do that again. 1 times 9 is 9, and that goes right there. Combine, we end up with 26. One more time. 1 times 26, and that goes right here, 26. Combine, that's 36. There are no other. Since this is not a 0, that means 1 is not my 0. So what do I do next, Mr. Q? I go to the next one. It could be positive 1 or negative. So now I'm going to test negative 1. 1, 8, 17, and 10. bring down 1. What is negative 1 times 1? Negative 1. Combine, that's 7. Negative 1 times 7, that's negative 7. Combine, that is 10. What is negative 1 times 10? Negative 10. Combine, that gives me 0. Now we found our 0. All right? Now that we have our 0, we're going to write this one first, and that one is x plus 1. Mr. Q, how did you get that? Remember when we first did the practice for the synthetic division where we got this number from? It was a binomial, yes? Let me go, I'm going to work it backwards so you guys can see it. I'm going to write this like this, x equals negative 1. To work backwards, I'm going to bring this one to the other side, so I'm going to add 1. I end up with x plus 1 equals to 0. And what was it before that? It was a factor, so that becomes that. That's where I get it. That's where we get this from. All right. So, what did we start with? A cubic function. Do you guys see this a cube? But since we already have one x out here, that means this has to be, instead of a cube, it's a what? X squared. So I write x squared, 1x squared. This is positive 7x. And this is positive 10. Notice in descending order. Now that I have that, I can factor this. Again, mind you, this process with this only works when it's a quadratic, trinomial, binomial, whatever you want to call it. So this is 10. This is 7. Factors of 10 that add up to 7, 2 and 5. I'm going to rewrite this. X squared plus 2x plus 5x plus 10. All right, let me group. GCF here is x. We're left with x plus 2. GCF here is 5. We're left with x plus 2. So what's the same here and here? X plus 2. And what's left? X plus 5. And don't forget to bring down the first 0 that we found, x plus 1, and all that should be equal to our function. What was our original function? G of x, was it? H of x. And this is the equation we were looking for. Okay? Now, just to show you why these are zeros. Remember before we went to break, we did polynomial functions, and I said, let's graph this. What was the process? Here goes the process. Look up, please. We make this equal to 0. So now that we have this equal to 0, that means that this times this equals to 0. Now, I'm going to do something over here that has nothing to do with this equation, but I need to make sure that you're understanding what I'm looking at. If I have something times something times something equal to 0, that means this could be 0. Is that correct? Yes? Because if this was 2 times 3, that's 6, but then this is 0, what is 6 times 0? 0. But since I don't know if this is 0, that means this one could also be 0. Because this could be a different number, this could be a different number. Or this one could be 0. So what does that mean, Mr. Q? That this could be 0, or that could be 0, or that could be 0, because it's a product or zero product property. So if this is the idea that we use here, this could be 0, this could be 0, and this could be 0. Do you agree with that? Yeah, so that means I can write it as x plus 1 equals to 0, x plus 2 equals to 0, and x plus 5 equals to 0. Does that ring a bell a little bit? Yeah. And if I was to solve this, minus 1, my first 0 is negative 1. Minus 2, x equals negative 2. minus 5, x equals negative 5. All right. How many x's do we see? 3. Or let me look at the original function that we started. What is it? A cubic function. What does a graph of a cubic function look like? It looks like that. It starts down here. There's something going on here, and then it ends on the other side over here. So this is the graph for this one. Let me show you what it looks like. Negative 1, negative 2, negative 5. And if it starts down here and it ends up here, then that means it should do this. And once again, what do we call these? X-intercepts, roots, zeros. And if I substitute any of these in here, what is it going to give me? A 0. That's why those are known as zeros. Okay? Now, do I want you to do this tonight? No. But if you want to practice ahead of us, you may do a couple of them like that, all the way. See if you can graph them. Does that make sense? But I want it all the way up to right here. I want to see the equation. Okay? Hopefully that helped. Once again, step 1, step 2, once you find your zeros, you're done. You just write your function. All right? So we're good with those, yes? Yes, Mr. Q. Before I move on, send me a picture of your notes. That was pretty good, right? Pretty good. Let me have some matcha. Okay. All right. Copy this one. Example 1 super duper cube. Copy that. All right, so let's do this one together. Here we go. It's going to go a little bit faster. Just want to make sure that now that we have all the process, let's see if we can do this a little bit faster, yes? I need a fraction with a constant and the leading coefficient. What's my constant? Leading coefficient? 2. Okay. All pairs of factors of 6. 1 times 6, 2 times 3. So my pairs of factors are 1, 2, 3, and 6. Factors of 2 are 1 and 2. Okay. What does that mean, Mr. Q? That these are going to be my possible rational zeros. So let's see. I'm going to go one at a time. What is 1 divided by 1? 1. What is 1 divided by 2? 1 half. Here it goes. I started with the first number, divided first by this number, yes? And then this same number divided by the second number. And that gives me 1 half. All right, since I'm done with this one, with these two, now I go to this one. What is 2 divided by 1? 2. What is 2 divided by 2? 1, and we already have it. We don't need to write it again. Next one. 3. 3 divided by 1? 3. 3 divided by 2? 3 over 2. And last but not least, what is 6 divided by 1? 6. 6 divided by 2? And we already have it right here. We don't need to rewrite it. These are my possible zeros. Did that answer the question with some of the problems on the home plate? Yeah, some of you were like, I wonder what to do with these that have a denominator other than 1. Okay? Now, what I did see some of you do, look up please. Some, I did see that they saw this fraction and they simplified before finding all the possible factors. Will that work? Yes. Like GCF at the beginning of everything else. But let's continue. All right, so where do we start? We're going to start testing 1 and then -1, and then from there I go to what? Half and then -half. All right, let's do this together. Here we go. 1. My coefficients are 2, 11, 17, and 6. Bring down the 2. Remember, the first number always comes down the same. And start with the process. What is 1 times 2? 2 combined 13. 1 times 13, 13 combined 30. 1 times 30, 30 combined 36. Since this is not 0, that's not my 0. And we're like, this is so easy. This is really fast. I know, right? So the next one, -1. 2, 11, 17, 6. Bring down 2 again. So let's see. -1 times 2. -2 goes right here. Combine, that's 9. -1 times 9. -9 right here. Combine, that's 8. -1 times 8. -8 combined, that's -2. We're getting closer. We started at a positive, now we're at negatives. But we're done with 1, aren't we? What do we go next to? 1/2. Yay! So we got 2, 11, 17, 6. Bring down the 2. All right? So let's see. What is half of 2? Half of 2 is 1, okay. Combine these, that's 12. All right? What is half of 12? 6. Combine, that's 23, Michael Jordan. What is half of 23? 11.5. And combine that, that's 17.5. This is not a 0, so nope. So what do we test next? -1/2. 2, 11, 17, 6. Bring down the 2. What is -1/2 of 2? That's -1. Combine, that's 10. What is -1/2 of 10? -5. That is 12. What is -1/2 of 12? -6. And we found our 0. All right, look up please really quick. Before you write this like we did the other one, this one is written a little bit different whenever you end up with a fraction like this. Let me show you how it's written. Look up please. I'm going to do this. X equals -1/2. And I want to get all of these numbers with x. But instead of just doing +1/2, I'm going to do it by parts. I need to get rid of the 2. What do I do to get rid of the 2? Times 2 times 2. Now I have a giant 1 there, yes? So I end up with 2x equals -1. How do I get rid of that -1? Add 1, add 1. We end up with 2x plus 1. And all that equals to 0. Therefore, my 0 that I just found, this, is written as 2x plus 1. Got that, Alex? Very good. All right, so let's see. We had started with a cubic function, and if we already have the x here, this is a what? A squared. So this is 2x squared. This is 10x, and this is 12. All right. Can we simplify this one by a GCF? That becomes x squared plus 5x plus 6, and now we can factor that a lot easier, yes? At 6, 5, product, sum. Product of 6 that add up to 5. 2 and 3. So we rewrite this. So this is x squared. Instead of 5x, we write 2x plus 3x. Bring down the 6. Group. GCF is x. We're left with x plus 2. GCF is 3. We're left with x plus 2. So my first factor here, which is the same as x plus 2. What's left here? X plus 3. That's my second factor. And what was my original that I found over here? 2x plus 1. And all that equals to, what was it, P of x? P of x. So I saw some of you kind of looking at me with this one. You're like, okay, Mr. Q, all right. Here on the side, put a little window. I'm going to give you a practice on changing this to a binomial. Let's say I gave you, we found that 1/3 worked. At the end, we got 0 remaining. That was our 0. How do you rewrite that? Ready? What do I do? X equals 1/3. So that means I need to multiply times 3, multiply times 3. I end up with 3x equals 1. How do I cancel that 1? Minus 1 minus 1. So this is 3x minus 1 equals to 0. So this one is written as 3x minus 1. You're saying, is that part of this problem? No, I'm showing you in a different window over here that it's not part of it. I'm just giving you extra practice on how to rewrite this. Let's do another one. One more of these, another practice. I want you to find me negative 1/4. How do we write that? So once again, x equals negative 1/4. That means we need to multiply times 4 times 4. That's 4x equals negative 1. Then right there we add 1. So we end up with 4x plus 1 equals 0. So my 0 would be 4x plus 1 as a binomial. Andrew, you got that? Yeah, we got this, yes? All right. So anyway, back to our problem. This would be our end result. Now let me show you an example from the home play that I saw some of you had some problems with. This one. So our constant is 4. Our leading coefficient is 1. So this is 1 times 2 times 4. over 1. So my possibles are 1, 2, and 4. Yes? So then I start testing 1. What is my coefficient here? 1. Look what I'm going to write next. 0. So you're like, what? This is x to the 4th. Which one would be next? X to the 3rd. Do I have it there? No, I need to write a 0. What's next? To the 2nd, so then I write -5. What's next? X to the 4th, x to the 3rd, x to the 2nd. What is next? X to the 1st. Is there an x to the 1st? So what do I write? 0, and then you write positive 4. Sorry. That's why some of you got stuck, because you remember that the practice was in standard form and fill in the gaps for whatever's not there. All right? And of course, the rest of it is the same way. All right. And last but not least, copy this one. And I'll get started just as you're copying it. 24 over 1, factor of 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6. So it's 1, 2, 3, 4, 6, 8, 12, 24. So my possible zeros are 1, 2, 3, 4, 6, 8, 12, and 24. All right, so where do we start? We'll start with 1 or -1. 1, okay. So then we got 1, -4, -7, 22, and 24. 1 times 1 is 1, combine -3. 1 times -3, combine that's -10. 1 times -10, -10, combine that's 12. 1 times 12 is 12, combine that's 36, that's not a 0. So to the next one, -1. These are easy. Bring down the 1. -1 times 1 is -1, combine that's -5. -1 times -5 is 5, combine that's -2. -1 times 2, -2 is +2. That combined, that's 24. -1 times 24 is -24. Combined, that's a 0. So what is my 0 over here? X plus 1. What do I have left? Is this an x squared? No, we started with an x to the 4th, so that means this is a what? X cubed minus 5x squared minus 2x and positive 24. Now we need to factor this one. I can try grouping, sometimes it works, but what if it doesn't? Let me show you what to do. 1, -5, -2, 24, and we start all over. That's cool, right? What are our possible rationals for this one? I'm only working on this one right now. 24 over 1 again. So what were my possible rationals? 1, 2, 3, 4, 6, 8, 12, 24. So I'm going to start with 1 again to find my second 0. Does that make sense? Kind of like a little Pandora box or something that you open. Have a good one, guys. Enjoy your home play. Once again, home play's on pages 348 and 349 odds only. Have a good one, guys. Enjoy your home play. Make it a math family night. Bam. Bye.